Hello and welcome back. Today we're going to be using differential equations in order to sketch slope fields and to match slope fields to their differential equations. So sit back and buckle up and get ready for a good ride here today, ladies and gentlemen. Well, what is a slope field? What is a slope field? A slope field is a differential equation that tells us something about the derivative of a function, and derivatives tell us slopes. So we had mentioned in class that differential equations are equations that have slopes involved. Dy dx you've seen, and x and y. A slope field represents this slope information graphically. So we're going to be looking at graphs today, so graphically. The technique to find a slope field is a sampling of several points x, y in a plane is made, and you'll see them represented as dots. At each of these chosen points, a differential equation is used to determine what the slope of a solution curve passing through the point would be. So you're really just calculating slopes using a differential equation. A small line segment having the determined slope is plotted at each of the corresponding points. So let's take a look at our first example. Here we have a differential equation. We have our dy dx equals negative 3x. And here is our grid here for our slope field. It's just an array of 25 points labeled on a coordinate plane. And what we're going to do is we are going to find the slope of the slope using the differential equation at each one of those points. So what am I really concerning myself with in this differential equation? It's just the x. So let's look. Here we have x is 0. So I plug in 0 in there and say negative 3 times 0 is 0. So I need to represent that with a little line segment showing the slope of 0, which should look like that, because this has a slope of 0, horizontal lines. Let's go here. Our x value is 1. So we're going to plug 1 into that differential equation and get negative 3 times 1. Well, what's negative 3 times 1? Negative 3. So we are now going to try to draw a little line segment representing negative 3. So that's kind of steep enough. It's negative, it's going down. And move on. We look at 2. We now plug the x coordinate 2 into the differential equation for x. We get negative 6. So now it's going to be steeper, but still going down, so like that. Let's go in the other direction. We have negative 1. Plugging in negative 1 into our differential equation, we're going to get a positive 3. So it should be about this steepness, but going positive now. Going here, same idea. Negative 2, plugging into our differential equation, we have positive 6. Steeper yet. All right. Now we go up to the next x coordinate, or the next set of row of dots, points. And we look here, x is 0 again, so we have this. X is 1 again, so we have negative 3. X is 2 again, so we have negative 6. Here, negative 1 on this side, going to the left of 0. We have negative 1, so it's going to be negative 1 times negative 3 is positive. For our differential equation, which is dy dx equals negative 3x. Same thing. Well, am I going to have to go all this? Or, well, we can see that all of these x's are going to be the same, so all of these are going to have the same little slope segments here. This would all be positive 6 at 2, regardless. Here we're going to have 3, so it should be as steep. These little line segments are there, little line segments. And then on this one, so do we have to do all that extra work? Of course not. That doesn't look very negative 6, or negative 3, I'm sorry. So, what should all of these line segments be? These little representations of slope. What should they all be? If you're thinking parallel, you would be correct. If you weren't thinking parallel, your answer may be right, but I don't know what it is that you're thinking. So once I'm finished, I have this array of points with little line segments, little tiny ones, representing the slope at each point. This is a slope field for this differential equation, dy dx equals negative 3x. Let's move on. Ooh, now we have dy dx equals y plus 2. Well, what do you think is going to concern us in this situation? If you were thinking the y, you would be correct. So now let's look. We have x is 0, y is 0. So we plug just the y value in. Well, where do we plug in the x? Nowhere, because there's no x. Just like in the last one, there was no x. So we're going to now plug this in, and we get 2. So we're going to draw a positive line with a slope of about 2. We go over here, our y is 0, but our x is 1, but our x doesn't affect this. So we draw another line segment with a slope of 2. We go over here at x equals 2, so this is the point 2, 0. Again, we only plug in the y. We get 2. Well, we're going to see that the same thing goes on this side as well. Let's go up 1. Now we're at the point 0, 1. Now we have 1 for the y, so we plug in 1 for y, and we get 3. So it's going to be a little steeper. I know it's tough. It's tough to see, and as long as you show a difference in the steepness, at least for the AP exam, they're not going to be that picky, because it's really hard for you to actually judge. You don't want to make this look like a 0 slope, because that's obviously not, or make a negative look like a positive. So just be careful with your line segments. The next one here is the point 1, 2. I'm sorry, 1, 1. We're only concerned with the y, so we're going to plug the y value in and get 3 again. We're only concerned here with 2, 1, so we're only concerned with the y value of 1, so we're going to put that in there. If you look, they're all the same. So we can just go right along. If you remember, go back a slide, all the x's. Remember, when all the x's were the same, we could just go right up and down all the x values. Now the y's are the same, we can kind of just go straight across. So we only have to find 1. If you look here at the point 0, 1, 2, so the 0, 2 is the point. It's going to be 4, so it's going to be yet steeper. And we're going to have to just go right across, because we know that for that y, it's going to be the same the whole time. Let's see what happens when we get negative values. So we're going to go down now to 0, negative 1. 0 doesn't bother me because it's the x, and we only have y in this differential equation. So we're going to put negative 1 in there, and look what happens. It's 1, so it's not as steep. And we know that that's going to be true all the way along this row. Go down to 2. I'm sorry, negative 2, 0, negative 2. Plug negative 2 in there. What are we going to get? We're going to get zeros. So we're going to graph 0. Now this is just a think about question. What if I get 0, I draw horizontal lines? What if I had an undefined slope when I did a differential equation? Undefined. What kind of line do you think we would draw for our slope field? If you thought a vertical line, you would be correct. A vertical line for something that's undefined. Slope is undefined. How about that? Moving on. Now we have x and a y in our differential equation. The differential equation we're given is dy dx equals 2x plus y. So we have x and y. So that means we have to pretend about x and y. So we have to plug both x and y in there. And some people do this. They actually work it out. So we'll do 0, 0. So 2 times 0 plus 0 is 0. Okay, so we just have a 0. Because it gets like a lot of work. So then the point, this is at the point 0, 0. Then they might do 1, 0. And they go, okay, well I know it's 2 times 1 plus 0 equals 2. Alright, so it's a slope of 2. And then at the point 2, 0, they'll plug in 2 times 2 plus 0 and get 4. I know it has to be steeper yet. And then they'll go the other way, negative 1. So negative 1, 0, and maybe negative 2, 0. We'll get 2 times negative 1 plus 0 equals negative 2. So here, I'm negative 2, so I'm going to be going down negative, and then plugging in negative 2 here. I get negative 4. So I get that negative. So you do the exact same thing. Now if you notice, there's no pattern, if you will. We can't just go up and down like we did with the first example, and we can't just go across with them. We have to actually figure out each one. And a lot of time on the AP exams, they'll just give you select points to figure out. Let me just do a couple more, and then I'll let you finish this one on your own. So let me look at the point 0, 1. And I'm going to do 2 times 0 plus 1, and that's going to give me 1. So I'm going to have a slope of 1. And I'll go up, let's just pick another random one. We'll do this one, negative 1, negative 1 as that point. We'll have 2 times negative 1 minus 1, or plus a negative 1 if you will. And that's negative 2, that's going to be negative 3. So that means this guy right here is going to be a negative 3. Alright, so that's how you sketch a slope field. In our next video that you'll see, we'll actually be talking a little bit about how I envision slope fields and how they work. But take a moment. If you haven't sketched this one out, draw it out and finish the rest of the points. Oh, okay, you talked me into it. I'll do one more up here. Negative 2, 2. Negative 2, 2. So 2 times negative 2 plus 2 equals negative 4 plus 2 is negative 2. So right here at negative 2, 2, we're going to have a negative 2 slope. There you go. You finish the rest. Alright, so please tune into the next video where we are matching or looking at differential equations and their slope fields. Alright, Johnstone, out.